Okay, good morning. Can you all see the screen?
We can.
All right, excellent. Well, good morning, and it is such a pleasure to be invited to the LSU 2021 Citrus Symposium. And what I really want to do is share with you all today is a presentation on the development of a citrus artificial intelligence, or AI, app to diagnose nutritional deficiencies, diseases, and some pests in the field. First and foremost, I'd like to go ahead and thank Dr. Arnold Schumann, professor at the University of Florida's Citrus Research and Education Center, for him and his lab doing all the research and development of this particular app and the information that we're going to talk about today. Also like to give Dr. Schumann credit for the presentation. He allowed me to use parts of his presentation, the majority of it, from a talk that he did back with us for a grower OJ break we did back in January of this year. So I want to make sure that I acknowledge Dr. Schumann and his lab for all the help that I've gotten in being able to put this together for you all today. Well, the objectives of what we want to talk about today are as follows. We're going to look at using leaf symptoms as a tool for diagnosing nutrient deficiencies, diseases, and pest management, and why is that important. I'm going to do a brief introduction to artificial neural networks and their potential use in agriculture. I'm going to talk about the development, the actual research of a smartphone app for diagnosing leaf symptoms using AI or with AI. We're going to do an introduction into the actual citrus diagnosis web app, and we're going to also discuss a little bit about using this information to make some management decisions, which ultimately, as an extension person, the research that is generated, we need to extend this to you, the growers, so that you can make better decisions, management decisions, and that's how this whole kind of idea of extension research works. So I'm going to extend this to you all in Louisiana. So diagnostics, well, why is that important? Well, they can indicate the presence or absence of specific diseases, nutritional deficiencies, determine if there's specific economically damaging pest levels that need to be controlled. There are also many times that you can find distinct patterns associated with herbicide uptake in the foliage of leaves, which is important in diagnosing those types of things. There's things like salt damage that also occur, whether that be spray damage or by uptake, and sunburn on some varieties of fruit that are exposed to sunlight on the exterior canopy of trees. So these are all things that tell us something about the condition of a plant and its diagnostic. Many times these symptoms are very similar, yet can be the cause of different issues. Today, determining the correct diagnosis usually requires many years of field experience. And take, for example, the photo that you see here in this presentation. Now, as an expert with lots of experience, I would look at those leaves and I would put that in a class of categories. Is that nitrogen deficiency? Is it Phytophthora? Or could it be girdling of that particular stem? Well, based on my experience, diagnostically, I would think, without knowing anything else but this picture, that would be girdling. And the reason why I would say that is that appears on the new foliage. Typically, nitrogen moves out of old foliage to new foliage, so you would expect it not to show up so much in the new foliage because it'd be moving in. If you look in the foreground, or the background, excuse me, of that picture, you'll notice that the leaves are green on the balance of the tree. So that leads me to believe that it's probably not Phytophthora, because typically that disease progression is such that by the time you see the veinal chlorosis, it's over the entire tree. So that's what this diagnostic thing can help us do. And that's where I think this app is going to come in and help a lot, is discerning some of these differences. And with, again, demonstrating the subtle differences in symptoms can oftentimes mean an entirely different type of corrective action. Varying symptoms that are specific to diagnosis, as this slide says. If a disease exhibits a pattern similar to a nutritional deficiency, typically you don't want to go out and spray manganese for iron deficiency, or you don't want to spray for iron or manganese for something like a greasy spot. infestation where you have a distinct pattern on the leaf, but you're not sure what it is. You don't want to go out and treat the wrong symptom based on not correctly diagnosing the situation at the time. As in Florida, the correct identification of nutritional deficiencies is critical when associated with an endemic HLB environment. So we have HLB, it's nearly everywhere. Well, it is everywhere, probably close to 100% infection. And with that infection, there comes some nutritional deficiencies that typically show up associated with that disease. And it's important because some of the research that we've seen, these minor elements that are deficient can oftentimes be beneficial if applied correctly. And a key to this is the correct identification of those deficiencies that allow us to choose the appropriate type of fertilizer to go in and treat these trees to try to improve the condition of the disease. And disease and pest symptoms on citrus leaves can also cause chlorotic patterns that can sometimes be mistaken for nutritional deficiencies, probably more so with something like greasy spot, maybe something like spider mites and HLB. If you look at those two leaves together there, the spider mites and the HLB, that blotchy mottle kind of pattern that's not symmetrical from one side of the leaf to the other can sometimes, if you're inexperienced, be confusing. And with greasy spot, you can have some of that spotting too, and that yellowing on the upper surface of the leaf rather than the bottom. And sometimes even you can mistake greasy spot, initial greasy spot infection for maybe the initial infections with citrus canker. So these are some of the things that diagnostics can do that, if they're done correctly, can help us determine exactly what the course of action may be. So now that we talked about the importance of this in relation to production, let's switch gears a little bit, and then we'll talk about what has happened with these artificial neural networks. And artificial intelligence, and as we have developed here recently, these deep learning models can help because they're fast and very accurate, especially these deep learning ones. And in research that has been done before with object identification, and this is some of the work that has come out of Dr. Schumann's lab. As you can look at this little slide here, hopefully you can see at least some of it. But in the different slide plates I have here, you can see where blooms have been identified. The next one, leaf flush, has been identified, off bloom, split fruit, sunburn, even psyllids have been identified, and also citrus canker. But these are looking at identifying objects. So we want to move that a little further, because what we want to do is be able to discern the difference. We're just not looking for a specific object. We're looking at more of a condition of symptoms. So that takes a little bit more knowledge. And that's where these artificial neural networks and the deep learning, deep convolutional artificial neural networks really started to take off in, say, like 2012. Because we started to understand these better, we could build these layers. The computer power and the hardware that goes along with being able to do this fast and efficiently has come a long way since that time. And they're excellent. They have excellent accuracy in image recognition. And the same technology is used for face recognition. It's used for image search engines on the web and even self-driving cars. So we wouldn't have thought of this kind of stuff 20 years ago, but today it's becoming more and more commonplace, and we hear these things. So that's with the advent of this deep learning kind of concept. So what does that, I guess, visually look like if you were to have a drawing of it? Initially, some of the simple neural networks would just have what they would call shallow, or they would just have one hidden layer. So you would have an input layer of what you put into the model, and then the network would look at that in this hidden layer, and then it would come out with an output. With the advent of these deep learning artificial neural nets, you get the input layer, and then you begin to see where you have hidden layers, multiple hidden layers, that better, and with each subsequent layer, looks at this aspect so that you get this a wide range of, in this case, symptoms that can be looked at rather quickly and give you a very accurate output at the end of it, because you're looking at more layers through this artificial neural network. And some of the stuff that's been done out of Dr. Schumann's lab, again, at least from some of the practical aspects of it, in object detection. This one is automated object detection of, in this case, citrus canker. As it goes by the tree, it can pick out the lesions of citrus canker. This is one that he worked with some colleagues at the Gulf Coast Research and Education Center in Baum, Florida. And in this case, it's mulch plastic, and what they're identifying in a herbicide demonstration or research is they're identifying nutsedge coming out of mulch plastic. And this technology identifies where the herbicide typically, or where develop the technology, and then you would only spray the nutsedge. So you wouldn't spray and waste spray on the bare plastic is the idea of why this object detection is important. There was also some work that he did with blueberry growers up in Canada, and one of their concerns is blueberries are non-climacteric fruit, so they don't ripen once they're harvested. So they need to be picked at the right quality, and quality is related to color in blueberries. So this detects the blueberries that are ripe, so that when it, you would take this technology through the field, you're determining when to pick, because nothing's going to be ripe all at the same time. But you want to choose a time when most of the berries are going to be ripe, and this can help do that will help with that situation, determining the timing. This is also another one that was done in Baum at the Gulf Coast Research and Education Center, and it's looking at strawberries on mulch plastic, and it identifies Carolina geranium that has come up through the plastic, and it's identified it separate from the strawberry plants. So then that's another benefit or another use of this automated object detection. So now we talked a little about the neural nets and why it's important to get diagnostics right. Now we're going to actually go into the science behind development of this smartphone app. And this was a Master's of Science program done by Percy in Dr. Schumann's lab, Mongofa, and the hypothesis was that there would be an AI, artificial intelligence, machine vision diagnostic system may outperform the diagnosis done by novice and expert scouts. So that was kind of the premise from which this project was based. And the objectives of the research project was to train a deep convolutional artificial neural network to recognize nutrient deficiencies, pests, and diseases on citrus leaves. Then to validate the performance of the trained network to identify symptoms on new and unknown leaf samples. Then to compare the model predictions with diagnoses that were made by nutrient concentration measurements, in other words, doing leaf analysis, and with human experts. Human experts would definitely come into play when they weren't nutritional deficiencies, because obviously you can't necessarily send off spider mite damage and have that come back from a analytical lab. So that was the idea of using human experts too. And then they wanted to augment the deep convolutional artificial neural network images with leaf symptoms representing other causes, pests, diseases, plant growth regulators, basically the unknown class. So it's been trained to identify certain things, and then the other, you have to separate out what it doesn't know to some degree so that you can reduce the background noise, so to speak. And then, not part of this project, but part of the overall, or not part of the research project, but part of the overall project was to develop and validate, finally, a smartphone app that will use this artificial neural network. So, as far as the smartphone app, it's used to analyze citrus leaf symptoms with a smartphone. So that was kind of the idea of doing this. So you have these different leaf symptoms that we talked about before, some of the diagnostic parts of this, and you can see that you have canker and spider mites, and some of these things are fairly similar. So you want to be able to separate these things out, and that's what the smartphone app theoretically is going to do. So what happened was, as far as the development of the research project, was the neural network training. So in order to do this, they took a collection of digital photos of symptomatic and healthy leaves. They took these photos with a standard Android smartphone camera at one leaf per frame. So you're taking one leaf with a smartphone camera. The lens that you use on the camera is not the selfie lens, it's the other side lens, which is typically better resolution. And that's important because you want these, in order to get good data, you want clear, focused images. And they did this on approximately 600 images per class. Okay, you may ask, well, what were the classes? Well, there were 16 different classes of leaf symptoms that we looked at. Nutrient deficiencies such as nitrogen, magnesium, iron, manganese, and zinc. And if you think about those, some of those are similar, so that would be important to be able to parse those out, so to speak. Pests such as spider mites, spider mite damage, leaf miner damage, thrips damage, and Asian citrus psyllid damage, and diseases such as HLB, citrus canker, greasy spot, citrus scab, and Phytophthora, along with a category of healthy and then unknown. And this neural network training went on. It was trained until convergence, and there were 9,600 leaves taken in this project of these 16 classes, both sides. So remember, it was 600 leaves. You had 16 classes. They were done front and back. So now you have a collection of photos that approach 20,000 high quality images of these symptoms. So that's how, part of the material and methods is how this neural network was trained. Continuing with the training, the validation for each system class was done. And then the photos for testing the model were separately obtained from independently sampled leaves. So we didn't use the same leaves. The trained model was used to predict with these test images. After photographing the leaves, again, laboratory determination of the nutrient concentrations were done by a commercial lab. And the validation accuracy was scored by percent correct diagnosis according to expert assessments of the leaves, as well as agreement with the nutrient concentrations that came back from the labs. So what did we find out? Well, after they got done training the neural network, the average accuracy of the 16 classes was 99.7%. The trained network was able to detect all nutrient deficiencies that it was trained on single leaves with 99 to 100% accuracy. It was able to distinguish between subtle differences in chlorosis expression between different symptoms, including dual symptoms like manganese and zinc, iron and manganese, and HLB. And this distinction between multiple symptoms is quite beneficial in real-world applications because it's oftentimes very difficult to parse out these multiple symptoms strictly by visual observation. I think at least from an experience standpoint, you would look at the leaves, you would identify the major deficiency, you would treat that deficiency. If it was subtle, a second one that was subtle behind it, you wouldn't notice it until you treated the first one. Wouldn't it be great if you could treat both of them because they were there at the same time? So that's kind of the nice thing about what this app kind of does is it looks at those and it comes up with these combinations of symptoms many times. And there's also some nuances as far as with diseases. There are leaf surfaces differences in pests and diseases from time to time. I'm thinking of pests, you would think leaf miner, it's on the back side of a leaf typically. And in this case, we're looking at the symptom lesions of canker and greasy spot. They're strongly developed on the lower surface of the leaf. And the model from a prediction accuracy standpoint is significantly higher for greasy spot on the lower surface versus the upper surface because that is where the infection initially begins, is on the lower surface of the leaf. So if it's initial infection, it does a much better job if you take a picture of the underside of the leaf versus the top side of the leaf. It still does well with the top side of the leaf, but from an accuracy standpoint, the bottom side with greasy spot seems to be a higher accuracy. And then the differences were non-significant for citrus canker since typically the lesions, once they start on the bottom, they penetrate the entire leaf surface, so it shows up on the top and the bottom. They also trained the AI image classification models, and what they wanted to do was compare these to novice individuals and expert humans at diagnosing leaf symptoms. And I have to apologize somewhat for this slide. It didn't come out as well as I thought it would. But these are confusion matrix that were done by Percy on her master's thesis. And what this shows is if you look at the on the left panel, those are the experts. The novice are on the right side. The left side, if you look, the darker green means that typically for healthy leaves, the experts got 100% of what it really was. And so the darker green means that you were closer to being 100% at your predicted label, what you think it is and what it actually is. So that kind of shows you on there that a lot of the experts, you see a lot more green down that center, diagonally center, and then you do over with the novice is what you would expect. Now, one of the things that's nice about this app is that it can help you pull out differences in that are subtle, because many times some of the symptomology is very similar for something like nitrogen deficiency and phytophthora, like we mentioned before when we're looking at diagnostics. So if you looking at this confusion matrix, that's typically where you see the experts somewhat falling a little lower than 100% or close to 100% is those things that are very similar, and there are very subtle differences. Can the app pick these up and then be able to help us do a better job of doing that? So what is this smartphone application actually? Well, what you do is you load up the app itself, and I'm going to have a short little demonstration on how you get signed up and everything for this, so you can all start using it just as soon as we get done if you want. But what you're going to do is you're going to open up the app itself. You're going to take a photo of a leaf. You're going to fill up the screen with a leaf. You're going to use the photo. You're going to submit the photo, and then it's going to give you a result. And this typically happens in a very, very short period of time, and we've got some demonstrations of that I'm going to share with you. This is an example of the page itself on your smartphone. What it typically will look like is you'll take the picture, you'll submit it, and then what comes back is this indication of a percent from the model on what that symptom is. So you'll see in this first panel that it's 100 or HLB at 99%, greasy spot at 92, and iron at 98. So that's kind of what the results that you'll get back will look like. Now, sometimes you might get a couple and sometimes you might get unknown, which you can address differently, and we'll talk about that here in a little bit. As far as the app itself, I've got a few quick little videos here. Hopefully these show up for you that demonstrate how this should be used in the field to kind of give you an idea instead of leave you out here hanging. So you open up the app, you'll go out in the field, you'll select take a photo, and then what you do is you'll go out and you'll look for classic or standard examples of the deficiency or what you're looking for. Put the leaf in focus, take a picture. So it comes back 99% iron, and then there's more information. You click on more information, it takes you to a page that shows you a little bit more about iron deficiency to reinforce the diagnosis, so to speak. And then if you click again, you can go and you can see the recommendations for treating iron deficiency in Florida. Here's one. Got the other one started a little ahead of time. This one is leaf miner. So if you'll notice that you take a picture of the leaf, you want the leaf in focus, and you want to take a picture of what it is you don't know is there, the symptom that you can't identify. You don't want to necessarily take the other side of the leaf, although it does work that way. It works better typically if you have a classic example of the symptom that you can use. Here we go. This is another example. This is another one where front and back. So you take a look at the back side of the leaf and it's 100% greasy spot. And again, you can go here, you can look at additional information, the recommendations for control of greasy spot in Florida, some of our university publications. or it's linked to university publications. And I believe now it will demonstrate using this app, the same leaf. We're going to flip it over, take the top side. Has good greasy spot symptom development. Comes back 100% greasy spot. Better figure out how to get to that one. Oop. Well, I think I got them too close together here. And maybe I can play that one. Oop. Well, we may have to forego this one right here. Oh, here we go. It is going to play. I'm sorry. Got them too close together. Here's just another quick example of looking for representative symptoms and then making sure that you collect one that looks typical to the ones that you're trying to identify. Here you go, manganese at 100%. Again, we back it up or reinforce it with additional information so that if there is some discrepancy in what the app is telling you, you can ground truth it with information that we have. And it's all built there where you can have access to it all at the same time. All right. A little about the app itself. Just let me explain that it only works as well as the data that is input. So it's important to consider the following best practices along with some pitfalls that would result in less than optimal performance of the app. And with the release of this app, we've noticed that there's, sometimes what we try to do is especially like when I'm out in the field, I try to see if I'm smarter than the app. And that's not the point of the app itself. The point of the app itself is to collect or take photos of focused representative symptoms of what you're trying to find so that the app can do its job. It's not to prove, like in my case, that I'm smarter than the app, because that defeats the purpose. What you want it to do is in these classes, it works very well. And so these are some of the, say, best practices on how to take a photo. So some of it is that you want handheld leaves. They work better if you hold them by the petiole or if you cradle them in the hand. The leaf needs to be in focus. I can't stress this enough. If you have a camera that has a depth of focus that's very deep, and you're getting stuff in the background that's in focus, this is not going to work very well for you. I have an iPhone, has a little red square, put the little red square in the center, make sure the leaf's in focus, take the picture. You want the leaf in focus. What's around it is kind of irrelevant as far as from a focus standpoint. You want the leaf in clear focus. And you want to use this vertical orientation with the petiole below, and you want to fill about 50 to 75% of the photo with the photo frame with the leaf. You can use, again, both sides of the leaf if you want. So that's kind of the idea of what a good photo is. Now, what you don't want to do is you don't want to use leaves that are covered with water or sooty mold or dust or other things like that. You don't want to take you want to take photos of individual leaves, not clusters of leaves, because what you're doing is you're focusing on the leaf symptom itself. You want to try to avoid artificial bright backgrounds that will produce unpredictable results. You don't want to hold the leaf in a horizontal position because the frame typically is more vertical than horizontal. You don't want it to be so far away that it's out of focus or that it focuses too much of the background and not of the symptom itself. And one of the things too, that if you take this and you go outside and you do it in direct sunlight and take a picture of a leaf, sometimes the reflected light off of that leaf with that camera isn't going to come back and give you an optimum response, because the leaf is can be overexposed. So you don't want to necessarily do it in bright light, but you don't want to do it in the dark either. So you want to take a photo of a leaf that has typically good contrast, that's visible good contrast, so that it can give you the results that you're looking for. Well, now, next what I'd like to do is I'm going to play a video on instructions on signing up for the app. This is, we're not computer programmers, and this is a smartphone app that is web-based. It's not one that you go to the Google or iPhone store to get. We're running it off of a server. So what I've got is because of that, there's some nuances to signing up to it, and we've had some trouble with that. So I thought I'd go ahead and demonstrate how that's done and what you should expect if you do this. The procedure I'm going to do is on a laptop in my office, or it's laptop, desktop. It's done on the web on a browser. So that's kind of how I'm going to demonstrate it with this video. But it's basically the same procedure if you're signing up on a smartphone. And there are additional videos that when you go to the sign up, if you do it on your phone, there are instructional videos on how it would look on a phone. It's very similar, but there is maybe a little bit of difference. You might get a little confused. So we're going to go ahead and I'm going to hopefully play this, and I hope y'all can see it and hear it all right. And then that will help demonstrate how you go about signing up, because it's kind of it is a two-part process. You need to sign up, and then you need to get a validation or an activation email. So we'll take a look at this now.
All right, good morning. As I had just mentioned a second ago, we're going to do this as a video in the presentation so that we can do a little bit better control of getting the login process down for you. And what we want to do is we want to actually Google search on the term "make citrus great again." And as you Google search this term, you'll end up on a web page where it says "make citrus great again." That's going to be the landing page for the Citrus Research and Extension Desktop. That is through Dr. Schuman's lab. There's a couple of things here that are of interest. The smartphone app itself, which is listed here, you can go directly to it. And after you sign up and you activate your account, if you need to log back in using this interface, you can go here to the actual login, the sign in, where you put in your username and password, and that will take you to the program, to the app itself, if you have to come in this way, so you don't have to go through all these menus. So for our purposes today, we're going to go ahead and just go through the normal process to show you where you would end up going. So you click the link here, takes you to the desktop, Citrus Research and Extension Desktop. Dr. Arnold Schuman's contact information is on this front homepage. Want to click on the smartphone app, and then what you'll do is you'll land on the research for the app homepage, so to speak. And it talks about the project, the objectives, the title of the project, what it does, doesn't do, and the personnel that were involved in the project. It has a couple little quick videos here if you have some more interest in this and how it's done. You can look at some of the resources that are available here on this page. The important thing for us this morning is we want to go ahead and get signed up to use the app. So where this flashing new is, you want to click to open the Citrus Diagnosis app homepage. So we're going to go to the homepage for the app. So this is actually the homepage for the app itself. The other one was the research homepage for the app, and this is the actual app itself, the homepage. And what it does is it has the instructions for which you need to use to sign up for the app, because it's kind of a two-step process. You sign up for the app. Once you sign up, you'll get an activation email. You'll click on the link in the email, and that will activate your account. Now you can come back and log in to the app itself. So we're going to go through this process. This is the first page you come to when you sign up. There's some additional interesting instructional videos that are down at the bottom here. They're not real long, so they're worth taking a look at, because what it's going to do is explain how you can go about taking pictures and getting those uploaded into the phone, like some of the other information that we've already shared with you this morning. But they go through it, so it's there for a reference if you need to use it. And also, if you happen to end up coming in this way and you already have an activated account and you want to go in and log in, you can just click right down here at the bottom and it'll take you to the login page. Okay, so what we want to do first is we want to go ahead and click here first. We're going to view the sign up instructions again. You're going to sign up, you're going to get an email, you're going to get an activation link, you're going to activate your account. So what we want you to do is, this is what the next page is going to look like. It's just going to have that little sign-up box right in here. But what you need to do is you need to come up with a unique username for your account. That could be from 4 to 15 characters, but it's unique to you. Whatever you want it to be, we're not assigning them. It's up to you. We do ask that you enter a valid email address, and that is required for activation. If you don't get the activation email, you can't use the app. So you put in a valid email address for yourself. Then you can make up your own password. We don't assign passwords. That's for you to decide what you want to use for this app. It can be from 5 to 80 characters. You want to write it down or remember it, and don't lose it. If you go and you go through the process of signing up, there's a box that, most of these apps have boxes that say remember me, so you can click on that. But if anything ever happens to your password files, then you need to have that so you can log back in to the app itself. So that's why we ask you to, if you choose to write it down, that's fine, or do something that's easy for you to remember. So final one, click sign up, and then you'll get, basically, we'll go through this and show you what actually happens when you click sign up, and you get some additional instructions. All right, so we see step 1. Now step 2 is click here to sign up. So we're going to sign up. I'm going to use a username. I'm going to use my notorious username right here, which is my normal initials and last name.
Normal.
I'm going to use my University of Florida email address, and then come up with my own unique password. At this point, we're going to click sign up. I'm going to tell it not to save. Now we're going to come to this page where it says welcome to the citrus diagnosis. And what we're going to do is click for instructions. Once we click here, there's another short video that will help you understand how to use the app. Notice right here it says important. Before you can actually use the app, log in to use the app, you need to get this activation code that's going to be emailed to you. So what we're going to do here is there's some additional instructions on, look at these instructions, click here for some tips. You can return back to the app. There's a few things here, and now what we're going to do is wait on that email and see when it comes. Let me switch screens here to see if it has arrived yet. All right, now we're at my email. What I want to do is send receive. And there it came. There is my activation. And there is my activation link. So now I'm at my email. I've got my activation link. Now I'm going to activate my account. So I'm going to click on this. And we're going to go back to the browser to see what that screen is. And now that we're back here to the browser, it informs me that a new account has been made and has been activated. And what I want to do is click here to use it. So I click on this link, and it brings me to the actual app itself. So now I've gone through the process of signing up, and I've submitted that information. I've gotten an email activation link email back to me. I've clicked on it, and it's brought me to here, where I can now put in my username, and then my password. All right, now I'm going to tell it to remember me, so I don't have to go through this all the time, and then I'm going to go sign in. Tell it not to save at this point, and this is actually the app itself. So this is the interface for the app if you're on a desktop or a computer, a desktop computer or laptop computer. This is what it looks like. And at this point, I got a few photos that I can show you how it works. You would do the same thing basically on your smartphone. when you download and you get logged into the account, you get to the app, you can go up there and you can save the link as an icon on your Android or your iPhone. And so you will have that icon on your phone itself, an app icon, and you click on it and it will bring you directly to this page. So you can, if you're out in the field, either drag or add a picture to the square, or you can take a picture with your phone. In this case, we're going to look at dragging some pictures that we've already taken out in the field. We're going to bring them into this app and have them analyzed just to demonstrate how it's done. So I'm going to come over here, click on this one, I'm going to drop it right there. I'm going to submit. And it's telling me that that's iron deficiency. So then I can clear that. Let's say I have another picture. Went out in the grove, somebody sent me an email, actually sent me a text message a couple of days ago and said, hey, is this citrus canker? As an expert, I would look at it and I say, looking just based on that leaf, I don't get to turn it around or look at the other side, but I feel pretty confident that that's probably citrus canker. Well, I can use this to help me better validate my opinion, or my opinion of whether this actually is citrus canker. As you see, it comes back 87% citrus canker. So that's how you can use the app. If you have it on a desktop, you can use it this way. If you go out in the field and you take pictures, you take your pictures with a camera, you can typically do it right there in the field. If you just take pictures and they're uploaded to the cloud, you can come back and use the desktop, and then you can drop the pictures in there to do the analysis. Or if you have a second camera rather than a phone that you use to take pictures of symptoms out in the field, and those are uploaded, or you download them to your laptop, you can then add those and go through those and have them go through the app here to give you an answer to what they may be. So with that, I think we pretty much have this done as far as the sign-up process. And now I'm going to stop this video and then we're going to finish up with the presentation. All right, good morning.
Okay, hopefully I'm back on track and y'all can hear me. And hopefully you saw the instruction video there to sign up. And one of the things about using on a desktop is in Florida, there are places out in the woods, so to speak, where citrus groves are. And a lot of times those areas may not have cell coverage. And because it is a web-based app, the pictures you take with your phone will stay with your phone. When you come into service, you can pull them back up and take a look at them. So from a standpoint of using it as an app on a laptop, that might be advantageous if you take some pictures and then when you come back into service, they'll get uploaded to the cloud. You can download them and look at them there or run them on your phone, just depending on where you are. It's kind of I think a added feature to having that is being able to do that if you're out in an area that doesn't have cell service and you can't run the analysis. So the smartphone app, some of the other spinoffs that I think are from this research is maybe trying to understand how the trained AI model is looking at when it diagnoses different symptoms. So try to make a sense of maybe what that app is looking at when it makes those decisions, so that possibly when you see unexpected results, maybe what the AI model is looking at is something that can teach us to be better at visually identifying symptoms of disease, of some of these diseases and nutritional deficiencies. So I think we probably can glean some of that information that can make us better at doing visual diagnosis. And another thing that we think can come out of this is to do an online leaf diagnosis training course using some of these 20,000 plus high quality images to help people be trained better in visual identification of these symptoms using the information that we have gained from this artificial intelligent model. And hopefully we're going to be able to add more diagnostic classes such as melanose, sooty mold, potassium deficiency, and some of these things into the future. So it's not a done deal. Teaching new skills. teach the teacher kind of thing. One of the things that it does do is you'll look here, there's a couple of photos. One of them here on the left is nitrogen deficiency with yellow veins. Now you have iron deficiency with green veins and yellow intervenal areas. And what you can do is the app is able to pick up the subtle differences when you combine the two, and you see the nitrogen plus iron deficiency with the intervenal chlorosis and yellow midrib. And knowing how that works and what that app is looking at can hopefully teach us to be better at visually identifying symptoms in the field. That's part of the proposal of, having an online type course that can help train us better. So conclusions: can an artificial neural network model be successfully trained to identify healthy or symptomatic citrus leaves, nutrient deficiencies, pests, and diseases? There was independent validation. Accuracy was 99 to 100%, with the mean being 99.7, and agreed with the expert diagnosis and chemical analysis. Additional leads for new symptoms are being collected and added to the app once the model is retrained. And the trained networks are being deployed to smartphones for in-field diagnosis of citrus leaf symptoms to not only extension agents, growers, homeowners, master gardeners, homeowner, grower types, and it's available for you also today and in the future if you go to the website and sign up for the app. There are some acknowledgments that I'd like to make. These are listed here: the CREC lab team, the Gulf Coast Research and Education Center, the ag teams, precision ag teams up in Canada, and also the funding, the HLB multi-agency coordinated MAC funds, USDA SCBI, USDA SCRI, the Florida Strawberry Growers Association, and the Wild Blueberry Producers Association of Nova Scotia. And there is Dr. Schumann's contact information, at least his email. If you want to know more about the nuts and bolts of the artificial neural net, Arnold would be the one to contact Dr. Schumann on that particular aspect. I'm the one that gets this out to you, explains it to you, gets it out in the field so y'all can use it. And I had just one more little thing that I wanted to run over here as I finish up my time. As we go through this and we have used this app and we have identified some malady, what do we do with that information? Well, one of the things that we have in Florida is what we call this citrus copper application scheduler, and that's the website for it. It's on a website that's called AgroClimate. And one of the things that I'm thinking would be beneficial is looking at this from the standpoint of, we know that copper acts as a fungicide and a bactericide. And with the app, maybe we go out and we identify that there's a certain pathogen that's out there that is susceptible to, that it causes a problem, but can be controlled by something like copper, such as, in this case, citrus scab, melanose, maybe greasy spot, citrus canker, or alternaria. And citrus canker, greasy spot, and scab are already built into this AI app. So if they identify those, then a typical control measure in Florida would be the use of copper fungicides, or with canker bactericide. So what this model does is it allows you to come in and put in some limited parameters. You can use the drop-down menus are for US or metric units. You can select a weather station. These are the FON, the Florida Automated Weather Network weather stations. So none of them are in Louisiana. But what it does is it's not so much the weather data from there as it is the rainfall data. The rainfall data you can put in yourself. You can upload a rainfall, basically a listing of rainfall in a comma separated file. You can upload that, and it will run the model using your data rather than one from a weather station in Florida. You can also pick the scion, whether it's round oranges, grapefruit, or mandarins, and then you put in your bloom date and your copper application dates. And so we'll take a look at that, what that looks like. So this is just a dummy run that I did the other day, but what I did here was I used a weather station that's in the Panhandle, at least it's in the same time zone as you guys, Central, and put in a variety, mandarin, and then put in a bloom date of April 1st, and then ran the date along with the dates of sprays. And what you can do is you actually put in the concentration of metallic copper along with the volume of water that you used in the sprayer. And then what that does is it goes through, and as you can, if you look at the graph, you can see where the rainfall occurs is in blue, and then you can see the amount of residual copper is the graph itself. So as that graph, as you add copper, make a copper application, the residual copper goes up, and as time goes and you get rainfall and or fruit expansion, this model also considers fruit expansion, that you can see where the residual copper is, and when it gets in close to that danger threshold, you can make another application of copper. So in that regard, it will help you schedule your copper for some of these diseases so you can better have an idea when to spray. How well it works in your area, you have spray schedules that you use. You might run this model in concert with what you're already doing to see how well it ground truths, but it's some additional information that you can put in to this model and compare to what you're doing to see if it could potentially provide you some additional benefit. And like I said, what it does is the simulation details, you can look at those, and actually what it does is it takes days from bloom, so it's considering the fruit growth and expansion, residue of copper, also considers rainfall, and then when you make those copper applications. So that's kind of a way that I kind of tied in the identification of using this AI, this app with something like greasy spot or citrus canker, well, let's say citrus canker for fruit and scab, and then you can bring that information back in, because now you're going to use copper to protect the fruit, and so you can use this copper model. So they all kind of tied together, to provide you with a better, potentially more efficient way of managing your particular citrus crop. So with that, that is the end of my slideshow, and somebody can, I think, take over.